Hi everyone, this video is the dosimeter educational kit assembly instruction. Let's open the box. Клейку вскроем. Inside the box we can see all the electronics with a case. Now let's move on to the assembly. Let's spread out the soldering mat so we can solder as conveniently as possible and we won't damage the table. Let's take the board and all the components. We don't need this fastening now, let's put it aside. Buzzer aside too. Let's keep resistors and transistors separately. Transistors pins, charging board. Kit includes resistors for 1 kΩ, 100 kΩ and 4.7 kΩ. It's important to not switch them. For soldering we need a solder, soldering iron and hand tools like wire cutters and pliers. Let's get started. Let's get ready for the soldering. First of all, we need to moisten the sponge. This is done either with glycerin or plain water. Excess can be removed, for example, with a regular napkin. We set the soldering temperature around 300 degrees. We take a soldering iron, wait until it warms up, wipe it on a sponge and remove the remnants of the solder. For this type of soldering, I recommend choosing this tip. This is a beveled cylinder. But in general, any soldering iron tip will work. The soldering iron is ready to go. Before we get started, listen to a short safety briefing. First of all, don't soldering in the dark. It will damage your eyes. Provide the working place with normal lighting conditions. Second, lay out the mat to not damage surfaces of the table. Third, the temperature of the soldering iron is very high. Don't burn yourself, please. Also, don't poke the wires with the tip. Wire insulation melts in a matter of seconds, which may lead to a very unfortunate consequences. Fourth, don't get close to the working area when soldering and use safety glasses when using hand tools. Don't forget that the solder tends to shoot when melting, and the flux can scatter very hot splashes when boiled. You also need to be very careful with side cutters. Therefore, it's necessary to use safety glasses. It's strictly prohibited to inhale soldering products, which are smoke and soot. In addition, they damage the mucous membranes, so you need to ensure the best possible ventilation. As minimum, open the window wider. I recommend choosing a good quality solder. Some cheap solderings do not perform very well, to say at least. Let's start soldering with the smallest elements, with resistors. They're marked both on the diagram and on the board with the letter R. Let's start with these two. We have R1 and N4. We need these two resistors of 100 kΩ each. Let's remove this paper shell of them and insert them into the board. Resistor is a passive component, so it has no polarity. Let's stick it on either side and bend its legs on the back side so that it does not fall out. Inserting the second one. Next, take a heated prepared soldering iron. Let's take a piece of solder, bring the soldering iron to the area of soldering and add a little solder. Since the solder already contains flux, we just need to heat it up. Let's install the remaining resistors according to the scheme. The next element is a diode. The same thing, removing papers. The polarity must not be confused here. It is indicated both on the diode body and in the form of markings on the board. Same steps. Inserting, bending the legs. Let's move the rest of the legs to the side so that they don't interfere, and let's solder. After we soldered all the legs, let's take the wire cutters and bite them off. In this operation, you need to be very careful. You need to hold the leg with your finger, because otherwise, when using wire cutters, the leg may fly somewhere, for example, into the eye. To avoid this, it's recommended to use safety glasses. it's recommended to put the garbage in some specially designated place, so that it doesn't interfere with the working process. You can, for example, use some paper for this. Let's continue the installation with the piezo buzzer. The same thing. Removing the wrapping paper. This can be done with cutters. The piezo emitter also has polarity. We need to take into account the plus sign on the board and on this marking. Accordingly, we insert into the plus and bend the legs. Well, nothing more out of the ordinary. We just solder. Let's move the legs to the side. Let's take a transistor. Here it is worth making a note. In early revisions of the board, they may be a narrow seat, but at the same time a transistor with wide legs. The legs must first be bent when straightened. This must be done carefully so that the legs simply won't break. Let's insert it until a click sound. Let's bend the two side legs, and the middle leg can be bent somewhere, for example here. If you have a small distance between the contacts, then you need to pay special attention to soldering so that nothing touches each other. So we solder very carefully. If it nevertheless happens that the legs touch each other, in this case you need to clean the tip with a sponge. To start with that, just try to remove it with a soldering iron, applying a soldering iron between the legs. Well, as you can see, I have everything removed. In case you can't do this, meaning eliminate the circuit with a soldering iron, a flux could help. If the flux is inactive, then you cannot even wash it off, just warm it. We are trying to remove all excess solder with such movements. The role of the flux in this case is to help the surface tension, so that it's all concentrated directly on each leg and not between them. Everything worked out. The next step is to assemble the transistor module. We had to put it on a separate board because it is surface mount SMD component. It would be quite a challenge for a new user to solder it. The main thing here is not to confuse the orientation. Pay attention to this black element. We should have it on the soldering side, so that the pinout remains on the opposite side. Soldering pins is not a very difficult task. You can clamp it like this with your hands. Let's bring the soldering iron tip, heat it up, and bring the solder wire. After we grab one pin, we can already put it on a table and solder the rest, while not forgetting about the very first one. It looks like this. The main thing is not to confuse the side of the installation. Then we need to stick it on the board. We see the following marking. A white stripe means that the board will be oriented in this direction. The main thing to make sure that nothing closes. Let's take some solder and use it. I'll try to make it as smooth as possible. No need to pay attention for the beauty of the job right now. Let's check the quality of the soldering, that everything is soldered correctly. In this case, everything is fine. Let's focus on this place. We make sure that no metal parts are close to each other. Here, as we can see, everything is okay. If something is crookedly soldered or closes together, then it will be enough to create pressure with your finger and heat it up with soldering iron. Alternately, warm the legs up and just press. Since everything is okay, we can return to the wire cutters and bite all of the excess. That's exactly what I was talking about. The legs flying off. Just hold secure with your finger. The next step is to solder the charger. For its installation, there is some pins. Let's cut them. We need to produce 6 single pins. This can be done either with wire cutters, either with pliers. 2 pins remain as spare parts. For soldering, we insert in turn all our pieces of the pinout. Next, install the module. It's important to make sure that it gets into all these pins. Let's solder first from the bottom side. We shouldn't pay attention to the size of blobs. We will carry out all the final soldering at the end, when we solder all the other pins of this charge. From this side, everything is soldered. You can put it on the table. Please pay attention. Don't drop solder on this board to avoid a short circuit, so you need to be very careful. If the solder doesn't lay down very well, then flux can help us here. Just a touch is enough for it to be applied directly at the soldering point. The soldering pads here are quite heat intensive, so don't be surprised if a blob is ugly. This is especially true for not very powerful soldering irons. From this side, everything is soldered. Now, when the module is standing stable, we can go to back and finish soldering. The blob of solder shouldn't be too big, but not too small. For example, this is a bad blob of solder. From this side we see soldering defect. Here the blob is large, not very beautiful, but still okay. This blob is good. And this blob is also normal. In order to correct the shape of the blob, we can use flux. If we use flux, then just heat it up and hold it for a while. The drop itself will become almost perfect due to surface tension. Here we can see that everything has become very good with all the problem areas. Next, let's take the VMS board and open the package. We don't need these pins, we put them aside. We will solder on these pins. The process is also quite simple. Let's solder here on this side. When this side became cold, we can take it by hand, adding a blob right here. Now the pinout holes. Let's do the same with the second one, so it will be as convenient as possible for us. When pinouts are stable, solder all the rest of pins. We can turn the soldering iron with this side and simply add solder to the soldering point. We are waiting that the solder will be applied both to the pin and the pad of the board. Now we are moving on. Here I intentionally left a bad blob in order to show how to deal with it. The same thing like we did earlier. Let's clean the soldering iron from excess solder and try to heat and break this jumper. Warm up a little on the top in order to make a beautiful shape. Then we can see that everything is okay. Let's take a closer look. Everything is fine. Let's go to the second side. On this side, this contact doesn't look good. As we already know, a drop of a flux can help us in this situation. We heat it up and everything becomes fine. Then we insert our result onto the board, acknowledging the orientation from this side. It's enough to put some solder to the corners and then we sequentially solder everything else. As we can see, VMS soldering was successful. Let's check that everything is fine. The next step is to solder the connectors. The connector must be oriented according to the markings on the board. There are two notches on the board. First of all, I solder one contact, just to keep the connector, and then I carefully solder all the rest once. An important note you need to pay attention to. The contacts in the connector are attached only to plastic, so the key is to simply not to overheat them during the soldering. If we hold at the place of soldering a little longer, then we risk our pin will start to crawl out of the contact, which is not very good. If this nevertheless happens, you can take something metal, support it from this side, and warm it up from the other side. Just press and try to set back. Now we can see that the pin is okay. We can solder everything else. As usual, let's check the quality of the soldering, and we may see that the connector is little crooked. The principle is the same like we did before. Press it with a finger, create pressure, heat it up and fix it. Everything worked out. The last component, as we can see, is the display. This is the most fragile component. Be careful with it. First of all, solder the pinout to the display. You need to be extremely careful with it. If you crush the corner, the display will stop working. We also need to try to not expose the matrix itself to thermal effects like drops of solder or a hot tip. Now let's plug it to the place. Let's solder one pin first to attach the display. Let's try to set it evenly, and after that we solder everything else. Before we turn off the soldering iron, we still need to solder the wires to the switch. That is very simple. The wire already being cut, so just insert the wire into the hole. Here we can see a bad blob, so only flux can help us with this. Let's add some, but not too much, so that it doesn't flow into the connector. And also we can prepare this part in advance. It's important to not overheat, because we can mechanically damage the switch. Here the hole was flooded with solder, so I am just going to solder it on top. If the switch gets broken, you can gently push this fork back with a soldering iron. Just heat it up here from the edge and try to press it back in. You can check it with a regular tester. And now the soldering process is completed. Set aside all soldering accessories. Turn off the soldering iron. Now we just need to clean the board. This is not necessary if you have an inactive flux. I will do this just for beauty. Let's clean it with alcohol, wiping with a cotton swab. Now the board was wiped, and just using a regular brush we remove all the remnants of the pile from cotton swabs. I do not recommend immersing the board in some kind of liquids, because we have a display here, we have a piezo dynamic, they just should not contact with liquids. Let's remove the soldering mat and proceed to the assembly of the case. First of all, you need to peel off the shipping film from the body elements. This process, by the way, is quite pleasant. Let's put the switch in place. And now let's prepare the fasteners. These bolts will mount the entire body. We will need this bolt to mount the battery, and these ones to fasten the board. Let's take main brackets. With difference between the front and back covers, it is the back one has these mounting holes. In this case, the main thing is not to confuse sides. Follow the sequence. The main board installed here, RadSens is installed here, and the battery box is installed here. That's why the side priority is very important. SBM20 or SBM20 tube, which has its own polarity, must be installed into the RadSens correctly. We focus on the plus on the board and insert the tube in such a way that the text is aligned with the plus side. Otherwise, RadSens will generate incorrect data. Let's install the RadSens board and fasten it. Now we will install the bud or the case with the switch. This is necessary in order to push the wire under the main board. One screw is spare. Now let's put the battery box right into its place. We also fasten it into the body using a washer. The washer is needed here in order to not create excessive pressure on the case material so it doesn't crack over time. With help of plier, hold the nut and screw it with your hands. Let's now connect the cables. And also connect the RadSens cable. Now let's assemble all the remaining parts of the case. The long part is located below, short one on top. The key is not to confuse the side, because it must correspond to the USB plugs. Before final assembly, insert a battery. Also, we can check that there is no bada boom. It would also be nice to remove the film from the display. And that's it. We now can move on to the firmware. The firmware can be found in the RadSens repository. Open the examples directory, find EDU folder. Now let's launch the Arduino IDE. There are three options to download the source code. The first option is to copy all the contents and paste to the file. The second option is to press Raw button and save the files from the browser. Let's create a directory and save the file with the correct extension. The third option is to download the entire repository. Save it, open, extract the archive and copy the project from here, pasting it into the Arduino directory. If the file has been downloaded, not copied, then just open it. Now let's set up the environment to work with ESP8266. Let's open the IDE settings. Here we need to put a link that contains a list of boards. You can find it either in the description of the video or in any guide how to work with ESP8266 in the Arduino environment. Click OK, open Tools, Boards, Board Manager, enter ESP8266. Select the latest version and download. Now let's update the list of libraries. Click Connect Library, Manage Libraries. We have two libraries in the project. Enter RadSens and install. And let's type Geiger't and install it too. Now we need to choose the platform we will work with. Choose Tools, Boards, ESP8266. Choose VMS, the Arduino 2 and Mini, and now we can build a project and check that everything is okay. If there is no error message, then everything is okay. Otherwise, you can contact our support or community in case of question. Now it's time to connect to the board with a USB cable. Let's connect directly to the VMS. Let's check which COM ports the board is connected to. Let's open Start menu, Device Manager, COM ports, and now we can see that it is COM5. Let's specify it here, and now we can load the firmware.